Hi everyone, welcome along to my video for how to answer question 3 on page 111. I'm going to give this a go. I'll probably muck it up as we go along, but we are going to be having a look at this question here. Okay, so number 3, looking at how you can explain why the formula for calcium chloride is CaCl2, and then we're going to compare that to calcium chloride, which is just KCl. So first up, we're going to look at calcium chloride. We're not going to worry about potassium chloride yet. We'll leave that for later. But the calcium chloride being CaCl2, we have to explain why or how we've got 2 chlorines for every 1 calcium. Okay, so the first thing you'll need to do is you'll need to look at how many electrons have been gained or lost by both calcium and by the chlorine or the chloride ion. So to start with here, we've got just writing down both of them. So calcium lost 2 electrons to become Ca2+. Now you've got your table of ions that you can look that up. You can see that calcium is in the 2+ column, and so you'll know that it's because it's got a 2+, that means that it's lost 2 electrons. Whereas the chloride ion in the table of ions is Cl-. Okay, you've got that table of ions in the back of your SciPad, so you can have a wee look at that. And because it's Cl-, that means that it's gained 1 electron. Okay, so because of this, we can do this with a picture. It's nice and easy. Remember, I'm only going to do the outer shell electrons. Okay, I'm not going to bother with anything else to show how we get this combination. So calcium, if we look at its outer shell electrons, it has got 2 electrons, because remember, calcium is number 20, so it's 2, 8, 8, 2. Okay, so it's got those 2 electrons on its outer shell. They are the 2 that it will lose to become Ca2+. If we then reacting that with the chlorine, okay, so chlorine is, well, chloride is the ion, has got 7 electrons on its outer shell. 6, 7, okay, 1, 2, 3, 4, 5, 6, one more, so 7. That means that it's got this one gap here that it can use to fill up that outer shell. Okay, so it needs to gain 1 more electron to fill up that outer shell. So calcium will give 1 of its electrons to chlorine, okay, to fill up that hole. Now chlorine's quite happy about that because its outer shell is complete. It's nice and stable now. However, calcium's still got 1 more that it needs to give away. So if we react that with another chlorine, which has got 7 electrons in its outer shell and still 1 gap, that 1 electron will go down here. Chlorine's happy, it's got a full outer shell. Calcium is happy because it's lost both of those and it's now reverted back down to the next shell, which has 8 electrons. Okay, so that's a full shell now that it's gone back down. And so from that we can now see that we need to make calcium chloride here, we needed 1 calcium to react with 2 chlorines. Okay, and so we've got our 2 chlorines and our 1 calcium. We would then, put that down as words. You could explain that as words, So this shows that calcium loses its 2 valence electrons to 2 separate chloride ions, okay, making CaCl2. Then what you do is you do exactly the same thing again, but you do it for the potassium chloride. Okay, so if we then did over here, potassium, okay, which is K+, because it's got the 1+ there, that means that it loses 1 we're going off the page, electron, okay, whereas the chloride here, which we did before, okay, which is Cl-, gains 1 electron. And because it's gaining 1 and potassium's losing 1, it makes it nice and easy. If you were going to do the diagram here, potassium has got 1 outer shell electron, chlorine has got, or chloride I should say, has got 7 outer shell electrons. So it's got a gap. That 1 electron goes into the gap over here. So we only need 1 potassium for each chloride. Done.